Hi everyone, CDM Smith team here is going to provide a training on New Mexico Dam Flood Inundation Mapbook processing toolset. In this video, we are going to demonstrate how to create a dam flood inundation Mapbook for a New Mexico dams. The takeaway from this training will be to have you know how to use the New Mexico Dam Flood Inundation Mapbook processing toolset. From the beginning, we will introduce how to install the GIS tool and introduce the interface of the tool. The best way to learn something new is to learning by doing. Therefore, we will go through an exercise step by step by using an example dams. In these training videos, you will see the questions raised by other attendants and learn how to solve the problems. The introduction of the tool applications and map structures will be also provided. Therefore, first, we will start this training by describing an example dam that will be used to create a dam flood inundation Mapbook by using this new GIS toolset. As you can see on the screen, SMBM number 2 dam is a flood control dam and located on a tributary of Rio Grande. Before generating a dam flood inundation Mapbook, we already delineate the dam flood inundation extents using FEMA DSSY's progress. Next, I'm going to hand over to the following training session to Allison. Hey, Allison.
Hi there, this is Allison Wagner, and I'll be running through an example of how we use this tool set for the GIS data example we're going to do. All right, so if we take a look at the File Explorer, this tool set comes zipped up because there are a number of files we've got to keep together. So I've gone ahead and unzipped it here. And if we take a look, here's what you're going to see. We've got these files right here, 2 template map documents for ArcMap, and then a toolbox as well. If we go further into the file structure, we've got some scripts written up, the 6 tools that we'll be running, and some additional base data and templates. These all get used by the tool. Probably best if you keep them where they're stored within this NM deliverable folder, and don't change the folder structure because the tools do require to pull on different things and they know where they're stored right now. Okay, and now if we go over into ArcMap, which I've got open, we're going to take a look at the catalog window over here. Now users can open up ArcCatalog itself and work from here, but it's pretty convenient to work in ArcMap and then just use the attached catalog window. That way we can see data and work with the files at the same time.
Hey, Allison, what's the required version of the ArcMap can use in this tool?
Yeah, that's right. This tool has been tested out with ArcMap versions 10.6 through 10.8. So that's what we'll be using today. Let's see, any other requirements? Requirements for this tool, part of it as we get to the later steps, is to have your default printer as a document printer. That is to say something like Adobe or Bluebeam. That's a little bit unusual, but it helps make the process move more smoothly as we're working with PDF documents here at the end. All right, so now we're taking a look here at ArcMap in the ArcCatalog, and we see this folder again with our documents, our different files that go into this. Now, users can access the toolbox here from ArcCatalog, but it's also possible to work with the Arc Toolbox itself, and we can load it up there. It does take a minute to load, but that's fine. One more thing we'll need to go over before we get started is preparing our data so that we know what we're doing here and we can enter in the different parameters that go into the tools. So while that's loading up, oh, here we go. Here's our Arc Toolbox. And we can add our tool here. If we search for it, add toolbox. And I've already navigated to where it's located. Here you see .tbx, that's our toolbox. We hit add or open. Again, this is taking another minute to load. And there it goes. Okay. The New Mexico Sim Mapbox tools. There it is with our 6 tools labeled out in order. Okay. We'll take a look real quick at what's required here to get started. That's going to go as our parameters in the first tool. So I'll open that up so we can reference it as well. And if we look back at our catalog, we can see some example data that I've got pulled out for today's lesson. Okay, now the first thing to know about working with this tool set is it wants you to use a very specific projection, otherwise it's going to throw an error for you. You will be able to use other projections if you'd like, but the way we've got it set up is that the map PDFs are going to be displaying in this projection here, WGS 1984 Web Mercator. And so it is preferred that you keep your data inputs in the very same format. Okay, and now I've got selected over here a number of files. What we've got here is 2 versions of inundation areas, a simplified version and a secondary, empirical smooth it's called. Now, something I do want to bring up here is that if we look back at original data that we got from our modeling outputs, this was done in DSS-WISE, those data actually had, those inundation shapefiles had a lot more detail to them. If we take a look at that here in the ArcMap window, there's areas of inundation, holes where there was no inundation, just a lot of detail. And unfortunately, with all the processing that ArcMap is doing, that amount of detail was too much. It overloaded the tools and they crashed. So I'm going to recommend to the users that they do smooth or simplify the results that they've got if they find that the tool is crashing. So our new version here of the inundation area looks like this.
And I have additional here. I think the polygon of inundation area definitely can import from the DSS-WISE output. And if a user use other hydraulics program like HackRace or Flow2D, they also can use in the GIS tool to convert the result to the polygon. And that, when you have an inundation area polygon, then you also can import to this map tool set. All right, Addison. Mm-hmm.
That's right. This tool will work with a number of outputs from different modeling software. Okay, I think we're getting closer to running our first tool. A couple of things we need here. We need to know the dam ID to be able to set this up. And so we better check that out. This is the Sebastian Martin Black Mesa Dam number 2. So we have provided here in our tool set the base data. So if you don't happen to know your dam number, you could search for it here in the attribute table of the dam's shapefile. Okay, and that would be the Office of the State Engineer dam number. If we search for it over here, I happen to know what it is already for our example data, so we'll go ahead and find that one. Yep, our example data is going to be D-439. Okay, and that's going to be our very first parameter. We need to know the dam number, so we enter that in. Next up, we can specify a folder location where our output data is going to be stored. Let's see, I've got a blank folder right here already called output, so I will pull that in. Now in ArcMap, you can pull things from the catalog into your tools, or you can search for them with the little folder button on the right. Okay, next thing we need to add into our tool is the scenario 1 inundation polygon. So here I'm going to grab that from our folder of data. Scenario 2 inundation polygon is optional, but we happen to have one this time around. If the user does not specify a second one, that's fine. The tool is going to run fine. It'll just exclude that one shapefile. Moving on, we need cross sections, but they don't have to be created at this time. We can create them at a later stage. I do happen to have cross sections right now, already exported from our DSS-wise model, so I'll pull those in. And the flow direction points. I happen to have those all ready to go, so I'm going to pull those as well. If you don't have them, they can be created at a later time or left out until the user gets more of a sense of what the Mapbook is looking like. The final optional parameter here is a photo for the index map page, so users get a little sense of what the dam looks like. So I've got a nice picture of our dam here. Open that, but again, that is optional. Okay, we've got our many parameters specified here. Again, the first three are the only ones that are required, but we've got a number of them here. We'll go ahead and hit OK, and that runs. So this step number 1, this tool is collecting our dam data together and also pulling a little bit of background base data so that we'll have everything all in one place for our map document. And if we take a look here in our output folder, now that the tool is done running, we've got a D439 folder, and inside of that, the geodatabase with a number of data collected. Okay, we specified all of those, but additional things will get added as we go through this process. Okay, next up, I think we'll move on to step number 2. Yep, let's go ahead and do that. Step number 2 generates our Mapbook extents. And so the remainder of the tools, most of them will ask you to pull in this geodatabase that got created. So we'll go ahead, bring that over into our tool, and that's the only input this time. Go ahead and hit OK. And it's creating our grid index of pages. We'll take a look at that. Okay, it's created a very simple index here. The attributes tell us there are 6 pages. And at this point, the user can edit what these index pages look like or the extents that they cover. So let's take a look how good of a job this is going to be doing. If we pull in our 2 inundation scenarios, okay, they are all entirely covered by the Mapbook pages. But you know, I'm going to make a change here. This very bottom extent and this edge here, they're very close to the edge of the pages. And now if we also bring in the cross sections, look at that, one of the cross sections falls off a page edge. So I'm going to select just the index pages and shift those a little bit so that they're covering our data set a little bit nicer. Okay, I'm trying not to let the cross sections cross pages, but it seems like that might be impossible up here. That one is crossing a page, but we've got them centered a little bit better here. All right, and I'm satisfied with how that looks. But
yeah, one question. So can we
yes.
just shift one single sheet, that one single grid, like 1, 2, 3, 4 from the top, a little bit left or a little west? Yeah,
we could, yeah. If we wanted to get a little bit more even coverage on this side of the inundation, we could shift it manually. I could go over here. Yep, cool. That's perfectly fine.
Thank you.
All right, in this case, we'll leave it as is, hit save, and we're done with this step here. Okay, following that, let's set up our map, our very first index map. So again, the first parameter of this tool is going to be our geodatabase. Pull that in. And now the user can specify on the index page if they want their company logo to be on there or their company name. So Let's see, we can add a logo here. Okay, and since we've got the logo, no need to add in the text name. That's fine. We'll go ahead and hit OK and have that run. We can see here any kind of output the tool is giving. And now that it's done, let's take a look at how that index map turned out. We don't see it over here in our folder, so let's refresh. And now we've got the photo stored here and the index MXD. So we'll go ahead and open that up, see how it looks. All right, it's taking a second to load here with the base maps. But over here in our table of contents, we see a number of our features. The dam shapefile got pulled in. We didn't specify that, but it automatically pulled in from our base layers. The index page that we just created is shown here. One of the reasons the user should come in and open up this index page is to make sure it's looking right. Now, we've tried to set up the tool to have it zoom to the right extent to show everything that you need to show here on your map. But if it's not looking right, the user can then go in and adjust the angle of display here or the extent by zooming in and out. And we see we've got a number of labels. If we don't like the way those are showing up on the map, we could always make a change there. We've got each of the following sheets specified and the dam labeled here at the beginning. Okay, and now we've got everything loaded up. We see some of the things we've specified. Our image showed up, a logo showed up here. We've got the date automatically generated for when this map was created. Additional information about our dam, the name, county is specified automatically. Dam number, automatic. And then it specifies right here who owns this watershed. And that came from the dam's base layer that was that has been provided for this tool set. Now, if in the future we notice some things have changed, it may be required for the user to update some of this base layer data that has been provided, specifically the dams layer. Say in the future there's a brand new dam that we don't have at this time in 2022, that would need to be updated. Okay, now I'm satisfied with how this map document is looking, so I say we go on to the next tool. Up next in our tool set, let's go this time to the Arc Toolbox and try that out. Oh, where did that go? Oh, interesting. Okay, it's not showing that tool anymore. I would have to load it up again. So I say let's continue using the Arc Catalog window. Over here, we can easily see our toolbox and move on to tool number 4, Generate Mapbook. Again, we specify the geodatabase that we're working in. Here on the following pages, this Mapbook generates the pages after the index page. Let's say we do something different. This time, instead of the logo image, we'll provide logo text. And here we're going to be changing additional text. So let's give a scenario 1 inundation description and the description for scenario 2 as well. Users can edit this text later when they open up the Mapbook, so we'll just give a brief description here. So scenario 1, we specified that one as the simplified version. For today, I'm going to call it simplified dam inundation. And scenario 2 was our empirical dam inundation. Again, those were optional, but the last parameter here is required. The user should enter the main river for the area of their dam. So in this case, we've got the Rio Grande. And now that we've got our parameters filled in, we'll hit OK and have that run. Great, okay. We've got to refresh one more time to see this map book. We'll go ahead and take a look at how that's looking. Now it's not entirely set up because we've got a few more steps to run through to get this all customized, but we can take a look, make sure it's looking good for us for the moment. Okay, we'll take a look at this. Okay, a quick look tells me we are on page number 1. If we turn on our data-driven pages toolbar, here, page number 1, it also says it down here, sheet number 1 of 6. Our dam inundation information goes here. This down here is a table of information about every cross section that shows up on a page. But for the moment, it's just showing the header row. We haven't gotten this table populated yet, so we'll be coming back to that. We look over here, there's some text. This text file, this text down here is what we specified the information of scenarios 1 and 2. Let's take a quick look at the left side of our figure. Legend is all filled out, that's looking good. We come down here, this is where the logo or company name would be updated. And then over here in our general note is where the main river name gets populated. Here we had entered Rio Grande, and that gets automatically populated into this general text. Okay, we see this is looking good for the moment. The next step here is going to make sure we can populate this table of information about cross sections. But to do that, we do need some information in the shapefile itself. So if we open up that attribute table for the cross sections layer, I happen to have added these 1 through 10 cross sections already, but we've got a number of fields that are blank. They're showing null at the moment. And so the user does need to specify what's going on here. You could start editing this. If we right click on the feature and choose Start Editing, we could go and fill in information for every cross section. So the distance downstream, say this one is 0, and it goes on from there. This is example data I'm entering. Usually engineers would have a separate table they could reference from the output of their model. The other fields that need to be updated here are belonging to scenario 1, these 5 fields. And then we've got scenario 2, the same 5 fields. So don't get confused. If you need more information, you can right click on the field and choose Properties. And here we've got a little bit more information. This is the maximum discharge for scenario 1, that's the one there, in CFS. Whereas if we go down to the same looking field down here, go to Properties, we can see that's going to be the max discharge for scenario 2 in CFS. Okay, so we expect the user to go in and fill this in at this time. And what I'm going to do here is, I've already got this information all pulled together, so I'm going to grab that from a different location instead of entering it all manually here while we're on video. Okay, so I've got my table here. Okay, so we're imagining now that I've gone in and populated this manually. We go ahead and stop editing now that we've got that data. And I'm going to exit our map here for the moment. Okay, the next step then is where we generate that table of the information to display. So we generate our cross-section report, step 5, pull in the geodatabase as we've done all along. And now we see this option to rotate the image. That's optional here because everyone's computer works differently. I find that mine does need to rotate to show up in the right orientation, but not everyone's does. So let's run this real quick and see how it looks if I don't check that. If I don't check that, we're going to see something kind of funny. So again, this is for my computer specifically. If I choose not to rotate it, my table shows up at a funny rotated angle. Okay, so that was bad. We're going to redo that with the rotate option checked. So rerunning the same tool with rotate. Okay, and now that the tool is finished running again, we can see it's orientated correctly. Okay, that created our cross-section reports. Let's go ahead and open up the Mapbook again and see if those are showing up properly on each page. Okay, we see we've opened up on page 1 again. And now this table is looking bigger. Let's take a closer look. Okay, excellent. We're here on page 1 and we can see results for cross sections 1, 2, 3, and 4. I see here we've got scenario 1 information populated and also scenario 2 information. Now, if you had only provided scenario 1 shapefile, then only one would be filled in and the rest would not show up at all. So it's great. This report template that shows up here is pretty automatic, as long as you've gone and filled in all the different numbers that you need to display. And so we move on to a further page, keeping an eye down here.
Real quick question. Scenario 4, like the cross section was barely on that page, right? Is there a way to remove it manually if you don't want it?
Okay, interesting question. There are a couple different things you could do here. You can always edit these TIFF files. Let's see, this was on page 1. We could go into the file here and kind of remove that information from the image. An alternative is that the user could run the report on their own. So over here in the view dropdown, reports, you can load a report. And since we have a template for how this is supposed to look, let's see, that's the wrong folder. We've got our template files .rlf here provided for the user. You could choose to run a report. And now, since we're on page 3, we're getting the same thing that's displayed here. But if we went back to page 1, and we adjusted the screen just a little bit, would that work? We're just showing 1, 2, and 3 now on screen. And if we ran the report, okay. Yeah, so yes, the user can manipulate the page and rerun a report to get the kind of output that they're looking for here. You would then need to replace the image that's stored in your D439 folder, and it'll automatically get pulled into the Mapbook. All right, so yeah, that was a quick example of how the user can go in and customize the map figure and the map reports after the fact. But yeah, the benefit of having this all automated is that if it looks good, then it's good to go. But again, the user can customize what they need to. I wanted to take a quick look here at future
another
pages.
way, yeah, and another way, maybe they can change the location of acquisitions.
Yes.
Yeah.
Should you need to change the cross-section location or information, you could do that. You may need to then rerun step 5, the cross-section report, to regenerate these reports here at the bottom.
And then the user probably need to go back to their original computer program in a ArcGIS or DSS-wise, redraw a line and read a number from the model output. Yeah. Okay.
Yes. Okay, it's very possible to go back and repeat these steps should you find changes need to be made. Okay, yeah, a quick look here at page 3 shows us that it's just showing the results for cross-section 6 here in the table. Page 4 has got cross-sections 6 and 7, it looks like. Oh, 6 is just up there. And we see here in the report 6 and 7. Okay, perfect. So let's see, I forget if I've made any changes here, but just in case, I'm going to hit save. And I'll exit out of our map. So we can complete our final step here in the Mapbook toolset, which is creating our PDF file. So let's go ahead and do that. Again, we just pull in our geodatabase to the tool and hit run. Okay, now the PDF is pulling from the 2 map documents we've got, the index page and then each of the following pages. So that'll take us a couple minutes here to run. And then in our output folder, we will have a resulting PDF. Now I'm thinking once we've got this PDF, we should go over any kind of troubleshooting issues that may pop up for the users. But here we'll take a look at our Mapbook PDF and see if it's looking good. Okay, we've got page 1 here. Yep, looks just like we saw before. Each of our subsequent pages. All right. Looking good to me. Oh, I did want to keep our guide open so we can take a look at any troubleshooting issues we might come across. Let's take a look at that. Okay, hopefully the user will have this troubleshooting guide as well so they can reference it. It does run through every step that we've gone through here in today's tutorial. And here toward the end, let's see what we're in, section 5-2, we've got a quality control check where we can take a look and see that everything looks as it should. So it tells you, the user specifically, to check these items. We've got a file path, the correct dam name and number, the dam showing up on our PDFs, and the tables looking right. Those especially need to show up correctly. And so we've already done that here on our example. Okay, anything else that we need to troubleshoot or look over?
We cover the issue. We need a default. We cannot default a printer for the computer to like a network printer.
Yes, I mentioned very briefly at the beginning that when you
So
run tool 5, when you run tool 5 to generate these table reports for the bottom, we do need to have a default printer set to a not a network printer, in fact, because the firewall can interfere with this, but a document printer. So for example, I've got my default printer sent to Bluebeam PDF, but you could also use, say, Adobe PDF.
So where to find a default printer?
Sure, we can take a look at that here. I've gone to my, well, here I am on Windows. I've gone to the Start menu and I typed in printer to get to the printers and scanners settings. It may be slightly different on different users' computers, but for example, on mine, here I've gone and found Bluebeam PDF. I could manage that, and here is where I would set it as the default. I've already got that done, but yeah, that's where the user could do it.
Because if a default printer is a network printer, all of the process may be blocked or stopped by your internal like a firewalls or security protections. So that will lead into not be able to produce the tables. Yeah, that's the troubleshooting.
Yeah, exactly. That has come up a number of times during testing, that the reports are a little bit finicky. They do need you to have a document printer as your default. Okay, any other troubleshooting issues you think we need to mention here, Max?
I think that's the two major one.
Okay.
I did not remember others. Yeah.
Great. Let's see. Yep, this is all stuff we went over in the tutorial. Okay. Let's see, anything further? I guess then we should move into any kind of questions that everyone has here on our tutorial today.
Any questions? Yeah, feel free to raise any questions if something confuses you or not clear. Yeah, or you have other like needed and yeah, we did not cover here. Feel free to raise the hand. And because before and while you guys thinking about the questions, I have one question. Will you be able to open attribute table of the flow directions? That will, yeah, helping the people. Yeah, what kind of information needed included in that attribute table?
Good point. We haven't really gone over this one feature class. Let's take a look at the attribute table, flow direction. And so what these are point features, and then they've got a rotation on them to specify at what angle the arrow should point to indicate flow direction. Let's see. I don't have a good symbol here ready to go. Let's see if we've got one. Okay, we'll make this our arrow, but it's not the right one. So if we were to just give it a simple symbol, well, all the flowed arrows are pointed in the same direction. So what we have done already for the user is to specify that they are rotated based on the specified rotation here in the attribute table. Okay, and I'm not doing this great on the fly, but let's take a look. Yeah, I can't say I'm getting this set up quite right on the fly, but hopefully the user understands then that this rotation number here specifies the angle of the arrow, and so what it should be doing here is pointing downstream.
So the map project we just create, do we have the flow direction show up on the map?
We do, yep.
Yeah, can we open that one? Yeah.
Okay, if we take a look.
Yes.
We've got flow direction over here in our table of contents.
So I saw one. So if for page 1, I saw the first one is 20 degree.
Okay, sheet 1, take a look.
Yep. So 20 degree means that all the way north is 0. So 20 degree were a little bit northeast, right? So that's the one.
Okay, interesting. It looks to me like these rotations need to be adjusted to accurately indicate flow.
Yes.
Okay, good point. A very good catch, and something that we need to do as part of our quality check after creating these files.
Yeah, and people can correct that by open the attribute table, change the angles or rotations.
Yep, that's right.
All right.
Okay.
Any other questions?
I have one. When we're putting them in, you were talking about how the non-smoothed out ones would cause it to like run too long and time out. Is that right?
Yeah,
I'm wondering like how we check for that. Like after 10 minutes of your computer not moving, is that when you get the hint, or is there a way you can tell that before you start?
Well, I'm saying we could try and run that and see how it turns out this time. But to my memory, I am thinking it would just keep running and running, and I would go and do something else and come back and it was still running. So it's either timing out after 10 minutes, say, or just not making any progress.
So here is my lesson learned. If your 2D model, the cell size is very small, that means higher resolutions. For example, 1 meter by 1 meter or 3 feet by 3 feet. And then your output, the inundation area polygon will have a lot of the turning point. So that means it's too much detail. When you put on the map, which is a PDF file, it's 11 by 17. That level of detail will not show on the map, but it will very struggle the ArcMap to produce this map set. So that's why it will take forever or never or give you the errors or warning message. So in order to solve this problem, and we actually don't need a level of detail on a hard copy of a map, so we need a smooth boundaries. So the step 1 I will do is ArcMap has a function allow you to smooth the polygon.
It does, yes.
Yeah. So will you be able to pull out that tool?
Okay. If we look here at the original outputs I've got here, here's one that we need to smooth still. And I go over to the search window and search for that smoothing tool. Let's get that right. Smooth polygon. Okay, that's the right one.
Yep.
Pull in our inundation shapefile as the input. And then we'll specify an output and the smoothing tolerance.
Yep.
Let's see. Did we make a recommendation in the PDF?
No, I will say that there's no exact answer. What's the tolerance you needed to use? You got to try and error. So for example, if we try 10 meters, which mean it's a 30 feet roughly, right? So then you will get a smoother the polygon edge than your original one. And try that one when you import when you're using the tool. If it still give you the issues, then you come back to using another number. Maybe next time try 15 meters or 12 meters. Just make as smooth as possible to allow the map tool to take. And sometimes you still need manually to have a GIS experts or engineer to look in some issue spot, like a too sharp edge or something to separate the small piece of polygon. And for that kind of issues, you probably need a smooth the sharp edge or delete the small polygon from the model output. So needed some massage or cooking in the kitchen. Yeah.
Yeah, now based on my experience, I would say it's these holes in the polygon that are creating a lot of detail, because ArcGIS has to then maintain the edges, the outer edges of the polygon, and then the inner levels of detail as well. So those might be chosen to be filled in if they're not that visible at the 11:17 map.
And those are small holes, in reality, practically the map it's commonly used to generate the inundation area, also the following the evacuation action development. So for the evacuation purpose, those small hole, it's meaningless. People we are not using a small hole to consider evacuation plan. Pretty much just like inside and outside the inundation area is the main purpose. Yeah.
Okay, we can't assume that people's lives are okay if they stay right in that polygon.
We will evacuate the majority of the inundation area. Yeah, people quickly move out from the area. All right, good questions. Any other questions? Okay.
Yeah, I have one question. It was noted that the tool requires the files to be in a specific coordinate system. Does the DSSY's results, the default coordinate system, is it the same coordinate system that this tool uses, or will I need to project the results into the coordinate system that the tool requires?
Now I'm looking at the result data we've got for our example dam, and those are in a different coordinate system. They're in NAD 83 UTM. And so those would need to be projected. If you don't, if you leave them as is, then you're going to get a warning. Now the tool isn't going to fail. We made sure that the tool would still run for you, but when you run it, let's pull that up here, you would get a warning. So yeah, it lets you know when that's not the case. And we do recommend that you use the WGS 1984 Web Mercator just as best practices.
Okay, sounds great. Thank you.
All right, I feel like we've covered a lot here. One last check for any more questions. Nope, anything else from you, Max?
Sorry, I was in the mute, talk to myself.
Oh, there you are.
Okay, so feel free to reach me and Alison for any further question, especially when you're really working on your own project. That I definitely we can image you will have more questions or need more guidance, and feel free to reach us for any questions. And yeah. So thank you. Yeah, thank you again for everyone joining the meetings. Hope this is helping for you, and feel free to reopen this video and watch that. Every time you open, you probably get something new. Yeah, and also feel free to share your lesson to the group. So yeah, all right. So thank you, Edison. I very appreciate your effort and this great trainings. Yeah, hope everyone have a great day. All right.
Great,
okay.
thank you.
Thank you.
Thank you for the presentation. This was really helpful.
Yeah, thank you. Yes, thank you.
Bye.
Bye.
Bye.